Activation energy. The definition of activation energy given by Merriam-Webster is the minimum amount of energy required to convert a normal stable molecule into a reactive molecule. A simpler explanation is that activation energy is the required amount of energy needed in a collision to destabilize the molecules in a substance. This allows a reaction with another substance to take place because the molecules within that substance are now able to rearrange themselves. An object's activation energy can be changed with a catalyst. Catalyst lowers an object's activation energy. Activation energy is not changed by temperature or concentration. Those variables only affect the amount of reactions that take place. Example. Imagine a kindergarten class. The kids are running around in a room. If the kids run into each other hard enough, they will get hurt. The activation energy in that situation is the force needed in the collision for them to hurt themselves. It's similar to a reaction where two molecules need to collide with enough energy, the activation energy, in order to react. Another example. A stick of dynamite does not explode on its own. It requires a separate reaction or fuse to get the molecules of dynamite to have enough energy, or not to have enough energy, but to lower the activation energy to a point that they hit themselves and the reaction can take place. Another example. The activation energy at the end of a match, the tip of the match, is lower than the wood, so that when you strike the tip of the match, the friction is enough to heat up and get the molecules in the match head moving enough that the activation energy is reached and the combustion reaction can take place, and then that combustion reaction reaches the activation energy of the wood, catching the wood on fire. When you graph activation energy, it's sort of like a hill, and the distance from the reactant energy level to the top of the hill is the amount that is the activation energy. Because it is the energy needed to be put in before the reaction can take place, and the line going down from the top of the hill is the energy being released from the reaction. A catalyst lowers the hill and decreases the activation energy required to get the reactants to have enough energy to have a reaction take place and release the energy into the product's final energy. Another example can be seen at this YouTube link, and it demonstrates the role of a catalyst in lowering a molecule's activation energy. Thanks for watching. I hope you enjoyed this nice video.